This video will introduce a number of standard discrete components that are used in many electronic circuits. Discrete components can be classified as either passive or active. Passive components, such as resistors, capacitors, inductors, and switches, require no power for them to operate. Active components, such as diodes and transistors, require power to operate. For example, a light-emitting diode or LED will only illuminate if power is applied. Additional information about discrete components can be found in the following books. Resistors. Resistors are one of the most common components. They are used to add electrical resistance to a circuit. The resistance of a component is a function of its physical dimensions and the material it is made of. The resistivity of different materials can be found in lookup tables. Resistors can be constructed using different techniques, such as wire wound, carbon composite, and film. The size, shape, and value of a resistor depends on the final application. For this example, we have a surface mount resistor with a value of 10,000 ohms. However, it can only handle 1/4 watt. This resistor has a value of 47 ohms, but is rated for 50 watts. Many resistors have fixed values. However, you can also get variable resistors and potentiometers. A variable resistor has a connection at one end and a slider which moves along. A potentiometer has a connection at both ends and a slider in the middle. Resistors come with a given value and a tolerance. The tolerance indicates the range of values a resistor might take due to differences in composition or manufacturing methods. This resistor here has a value of 47 ohms and a tolerance of 5%. If you purchase a 100 ohm resistor with a 10% tolerance, you are likely to get values as shown in this distribution. This leads to an interesting question as to what values of resistor are manufactured. Using the 10% tolerance example, if you took a decade of resistor values and applied tolerance bands, you can see that there are both gaps and large overlaps in the values you could get. To overcome this, manufacturers make resistors according to a logarithmic scale. This minimises the number of gaps in resistor values and the overlaps. There are standard series of resistors known as E-series. Each E-series has a fixed number of resistors in it and a fixed tolerance. The E6 series has 6 resistors in it and has a tolerance of 20%. The higher the E number, the higher the tolerance and the more resistors in it. The E96 series has 96 resistors and a tolerance of 1%. Characteristics of resistors that may be of interest include tolerance, power dissipation, operating temperature range, stability, and temperature coefficient. Values for these can often be found on the manufacturer's component datasheet. Capacitors. Capacitors are passive devices which store electrical charge. They are often constructed from 2 conductive plates separated by an insulating material called the dielectric. The capacitance of a capacitor depends on the physical dimensions and the dielectric material. The dielectric constant or relative permittivity of a material can be found in lookup tables. The 2 main types of capacitor are ceramic disc and electrolytic. Ceramic disc capacitors are primarily used for noise suppression and are relatively safe to use. They come in small values from picofarads to microfarads and are not polarity sensitive. Electrolytic capacitors are made of aluminium or tantalum and a conducting liquid. They are suitable for high capacitance values and are used in power supply filtering. Unfortunately, they are polarity sensitive, and if reverse polarized, they may explode. This is an ultra slow motion video of a tantalum capacitor exploding. It is very important to ensure that the capacitors are placed in the correct polarity on your printed circuit board, otherwise it could have disastrous consequences. Switches. A switch is a device which allows an electrical circuit to be broken. Switches can be operated manually or electrically when they are known as relays. There are standard terms associated with switches: pole, throw, normally open, and normally closed. The number of poles indicates the number of separate circuits the switch is connected to. The number of throws indicates the number of wiring paths available to the switch. Here are 4 common switches: single pole, single throw, single pole, double throw, double pole, single throw, and double pole, double throw. The 2 most common physical switches are toggle switches and push button switches. Toggle switches stay in position once you have operated it. Push button switches return to their default position once you have released them. Push buttons are either normally open or normally closed. This indicates their default state when released. Other types of switches include rocker, slide, or rotary. Light emitting diodes. LEDs are a special type of diode which emit light when a current is passed through them. The details of how they operate and generate light are covered in the electronic materials unit. LEDs come in a range of colours depending on their construction material. The important parameters to be aware of are the forward voltage and forward current. These can be found in datasheets. LEDs usually require a resistor in series with them to limit the current. The brightness of the LED can be changed by varying the series resistance. Transistors. In this unit, the term transistor refers to bipolar junction transistors, or BJTs. BJTs are a semiconductor device which revolutionised modern electronics in the 1940s. They can be used to amplify or switch electronic signals. This unit will only consider them as switches. Details of how the transistors are made and their operating modalities will be covered in the electronic materials unit. There are 2 primary types of transistor, PNP and NPN. The names are derived from their physical structure. In this unit, we will consider transistors as electronic switches. The input voltage applied to the base will either open or close the switch. For NPN transistors, applying 0 volts will open the switch, and applying 5 volts will close it. For PNP transistors, it is the opposite. 0 volts will close the switch, and 5 volts will open it.